This point in time, I'll be able to discuss some nuclear reactions. Not really that discussion, it's really giving you an examples in order for us to familiarize the chemical reactions for those nuclear atomic particles. So considering the Dalton atomic theory, okay, we have a lot, right? We have the alpha emission, beta decay, electron capture, electron, proton, neutron, positron. Okay, so we will mix those basic concepts in different examples. So I will give you now the examples. Okay, so let's have, I'll get some examples in the reference materials. Okay, last night. Okay, so I have here, okay, number one is nuclear reactions, right? It's nuclear reactions. Okay, nuclear reactions. Okay, number one example we have, okay, 210, okay, 84, like this. What's this? This is polonium, right? Polonium is equals to 4 2 H A. Okay. Number one example. 210 polonium, 84 42HA. Now the first thing to do, or the first step to do, is to identify what radioactivity process of this, and then you will be able to insert and to use those, could it be alpha, beta, proton, neutron, positron, like that, and everything you will apply that here. Okay, since we know this is 42HA helium, so this is alpha emission. Alpha emission usually plus here in the product. Okay, so here polonium mass number 210. Okay, atomic number 84. Okay, like that. So our answer will be like this. Okay, plus, so let capital M as our mass number, let capital A as our atomic number, and let E as our element. Okay, let M is our mass number, let E is our element, and let capital A as our atomic number. Okay, now use simple algebra for this. Just simple mathematics, even an elementary student can obtain. Okay, solution will be 210 is equals to 4 plus m. Considering the mass numbers first, okay, 210 is equals to 4 plus m. And so for the value of m, okay, 210 minus 4, so m is equals to 206. So simple mathematics, okay, 210 minus 4, so m is equals to 206. And then this is for the upper portion, the mass number. Second step is to compute the atomic number. Okay, atomic number is equals to 84 is equals to 2 plus A, then A is equals to 82. Okay, so computing for the atomic number, okay, like that. So simply 84 is equals to 2 plus A. So meaning to say, if we try to understand this in a very quick manner, so this is the mass number of the reactant will be equal to the mass number of the products. The atomic number of the reactant will be equal to the atomic number of the products. But these are all total. Or the total number of mass number in the reactants equals to the total mass number in the product. The total atoms in the reactant is equals to total atoms of the product. Then solve for the value of the variable that we are trying to obtain. So E is the element. So after getting the atomic number, we know already the element. Okay, our element is 82, right? Because atomic number is 82. So we will put each here. Okay, 206 is 82. So like this. N is 206. Okay, A is 82. Then we will find 82. What kind of element is this in the periodic table? Okay, so 82 is, oh my gosh. So okay, wait for a while. I have to find that here in the desktop. Okay, okay, because my other mobile phone has no data, so I will be able to get the element. What kind of element? Before we're going that, let's have number 2 first while opening the desktop computer. Okay, like that. So we have, I have the example, sir. 14 7 nitrogen plus, okay, 1 0 neutron is equals to, okay, like that. So let's find out which element that has an atomic number of 82. Okay, okay, this is our second example. If you have a blank sheet of paper that you can solve by yourself. Okay, 14 nitrogen 7 is plus 1 and 0. This is neutron particle. So meaning to say the nitrogen is bombarded with neutron. Okay, like that. Okay. So voila. So that is I will try to search element that has 82 atomic number. Okay, I will search. So this is lead. So in number 1, the element that's an atomic number of 82 is a lead, capital P. The symbol is capital P, small letter B. Okay, because of the plumbium. Okay, like that. So it's become PB. So this is the lead. Okay, number 2, this one. So this is the neutron. Then it's very clear that it will produce a proton, 11P and or 11H. Okay, so this is 11H, okay, plus N A E. So the same story with 1. This is the same story with redox, ha? Our reaction or our chemical reaction is always plus. There's no negative. We don't say zinc minus lead is equals to like that. All chemical reactions are plus sign. Here, plus, plus like that. Okay? So solve for the value of M, A, and E. So the same story with number 1, simple algebra only. So consider first the mass number. Okay, something like that. Okay, 14 is equals to 1 plus M. So M is equals to 13. Okay, and then 7 is equals to 1 plus A. Then A is equals to 7 minus 1, so 6. This one. It's gonna be like this, huh? For number 2. Take a look. We don't include the 1 and 0 because that is only the the element that bombarded with this nitrogen. Okay, and it will produce a proton. Okay, like that. So our M is 13, our A is 6. Then what element is this? So 6, I think this is carbon. Okay, 6 atomic number. Okay, atomic number 6. Okay, so this is carbon. Number 2 is carbon. Okay, like that. Okay, and then another example. Okay, another example will be number 3 here. So we have 201 mercury, 8 Hg plus 0, -1 electron, like this. This is number 3 example. Okay, look at the example. So 0 E -1 is an electron capture. Okay, or this is undergoing a beta emission that produces beta particles. Okay, something like that. Okay, now in the principle, if there is an electron capture, so in this situation, this will produce gamma ray. Okay, gamma radiation, which is like this. This is a concept, huh? Gamma like this. 0, 0. So this one. This is a gamma ray or an X-ray. If we have an electron capture added with this mercury. Okay, this gamma ray. The gamma ray has a mass number of 0, an atomic number of 0, or shall we say the 0 is a nuclear charge. Nuclear charge for the particles. If this is an element, this 0 is atomic number. But there's no atomic number of 0. So the right technical term for this is the nuclear charge, or the charge of the nucleus. Okay? Bear this in mind that the number of protons is always equal to the atomic number, huh? Okay? Like this. So we need to solve for the value of M, A, and E. Okay, so we have this. 201 is equals to 0 plus M. M is equals to 201. So M is equals to 201. So in an electron capture, okay, the element you are added here, the mass number will always equal to the product. Nothing changed. For example, if this is 201, so your M also here will be 201. That is the theory behind. If it is 201, 201 also the M here. Okay, like that. So to compute for the atomic number is equals to 80 is equals to 0 plus A. A is equals to 80. Oh, no, sorry. $80 plus -1 is equals to 0 plus A. Then A is equals to just transposed, okay, 80 minus 1, A is equals to 79, okay, like this, okay, like this. Actually, this is the mass number here is equal to 0 plus m, right? 0 plus m. Actually, you can also add 201 plus 0, okay? But 0 is just simply 0. That's why 201, okay? Like this. Because reactants and the products man siya. Okay? You understand the point? Okay? So like that. So we need to find the element 79, which is element that has an atomic number of 79. Okay? Atomic number 79. This is gold. Gold or AU. So in number 3, the element we found out that is a gold or AU. Okay? From aurium and auric. Okay. Like that. So this is gold. Okay, number 4. Like this. Okay, we have here 238. Number 4. 238 uranium plus 92 plus 12 6 carbon is equals to. Number 4, this is the nuclear reaction. In here, in the Fury, this will produce neutron. Okay? Like this. Because I already taught you yesterday the standard formula or concept to apply. Okay? Then you have to memorize that one. Because that is really already the scientific principle. And then you don't have to alter that principle, then you have to apply that in an example. Okay, like that. So neutron 1 0 neutron plus M E A. Okay, this one. And solve for the volume of capital M. So 238 plus 12 is equals to 1 plus M. M is equals to 238 plus 12. I have the calculator now. So 10, 4, 5, 250. Okay, so 250 minus 1, 249. Our M is 249. Like that. But in this situation, we have to put 6 here. Just because of this, okay, in the principle for this, in the situation of carbon element to be added to different radioactive materials or radioactive element. So carbon will be added 12C6, and we have to use the principle that we need to put 6 in the end. So like this, 6. Okay, then this is wrong. So we have the, okay, 6 times 1 plus M is equals to 238 plus 12. I almost forgot. Okay. So M is equals like that. 250 minus 6. 244. So our N here is 24. This one now. Very dirty. Again, I have to draw that one. If you add carbon element, the atomic number to the first element in the product should be in the coefficient. Okay? Again, I will write here. So this is the theory already, and we don't have to modify the theory because that is a theory. 12, 6 carbon. That is a 1, 0 neutron plus M A E. Okay, like that, huh? So we have atomic number of 6 in the carbon element, and you have to put that in the coefficient in the neutron. So this will become like this: 6, 1, 0, N plus M A E is equal to 2, 3. The mass number of the reactant is equal to the mass number of the product. So 12 is equal to so this one you have to times the 6 and 1 here because it is referring to the charge. Okay, 6 times 1 is equals to M, and then our M will be 250 minus 6. That is 250 minus 6. That is 244. Our mass number is 244. Okay, and then our atomic number will be 92 plus 6 is equals to 0 plus A. Then A is equals to 98. 98. Okay, and then you have to find 98. What element is that 98? That's the carbon atom of 98. Okay, so 98, you have to find that here like that. 98. Okay, that is californium. Okay, californium. The example number 4, we obtain a californium. Since we added a polonium, okay, that's polonium, right? Sorry, we added a uranium to the carbon element. In radioactive substances, radioactive elements such like this, the usual addition will be the carbon element and will produce a neutron, okay? Uranium is a radioactive element, and it will produce a radioactive element also, which is the artificially prepared metal, which is the californium, because it has an atomic number of 98. Okay, like that. So this is gonna be like this. I only have 4 examples, and the rest you can understand also. Okay, so a lot of examples for this, and then you have to use those concepts that I discussed yesterday. Then you can get, okay, the answer. Bear this in mind that we will use always plus in mass number in the reactant is equal to the mass number to the product. Okay, atomic numbers in the reactant is equal to the atomic numbers in the product, like that. So meaning to say in equilibrium, because there's a chemical reaction, nuclear chemical reactions in equilibrium, something like that. Okay, the same as balancing of equation, the total numbers of atoms in the reactant is equal to the total numbers of atoms in the product, and then everything will follow if we have the variables. Okay, something like that. So I must introduce another formula also, so that it's very clear in your mind before I will end this live streaming. Okay, so we have the protons. So protons is equals to 1 like this, huh? This is for proton. Proton. Okay. Neutron 1, 0, and this one. So bear this in mind. The numbers on the bottom is the atomic number, is equals also to the number of protons, and this is the nuclear charge, or the charge of a nucleus. Written in the lower part is this one and this one. This is the mass number. Okay, so the formula will be mass number is equals to the mass of the proton, mass of the neutron. This one, equation 1. This one, mass number is equals to the number of proton plus the number mass of the proton, mass of the neutron. Nasir,
Sotero.
good morning.
There is.
Likewise. Okay, guys, and this number 2. Hello, are you still there? Okay, number 2 will be neutron is equals to proton plus electron. This is equation number 2. Equation number 3 will be like this. Okay. This is neutron, this one. Neutron is equals to proton plus electron. Number 3 will be the proton is equals to the neutron plus the positron. Okay. Question number 3. Proton is equals to neutron plus positron. Positron is the small letter P. Okay? Okay. And another formula also. This one. Electron negative is equals to the atomic number plus the charge. Question number 4. Sorry. Question number 4 will be electron is equals to the atomic number plus the charge. Okay. This is in the case, for example, having charges. Okay. For example, sulfide negative 2, this one. Sulfide negative 2. So if the question will say like this, what is the atomic number, what is the mass number, then you have to follow this. Okay, like that. Okay, and then you know that the sulfur has the atomic number, so you can compute with the mass number like that. Or for example, in the question there's a given for the mass number for this. Okay, and you can compute for the charge. Okay, in here, electrons because atomic numbers, but there's a charge. So atomic number and electrons you don't know, and you have to solve for this. For example, if there is an atomic number for this, you can solve for the electrons for this sulfide, something like that. Okay. Another example also, if the question will say like that, is iO2 negative, like this. This is silica like this, silica dash 129. This means that this 129 is automatic the mass number. Okay, and the rest will follow because you know already what is the molecular weight of this is like O2, and then you can solve for the number of protons because atomic number is equal directly to the number of protons. So you can solve for the protons, electrons by having this formula and by having the other formula I mentioned a while ago. Okay, like that. So number of protons is equal to the atomic number. This is the nuclear charge or the charge of the nucleus. Okay, something like that. So this topic also apply the the theory of charges. Okay, electrical charges, blah blah blah, so and so on. You have to understand. Okay, thank you so much for listening for this live streaming. I hope you like this, and if you gain a little bit of information, then you can share to anybody else, or you can comment in the comment section down below in my in my uploaded video later, and then subscribe if you want to subscribe. Please support me and subscribe my channel, and then you can also click the notification bell if there is, and then for some of my newest updates regarding occupational safety and health science, pure sciences, personal vlog, singing, entertainment. Thank you so much. Bye bye. God bless everybody. See you later.